unit method, which basically takes pretty complex electrical engineering topics and basically simplifies them to a standardized form that is a lot easier for calculations, because in a radial transmission line you could have hundreds of transformers and then different voltage values of each one of them. So this whole thing basically just simplifies it. But here's an example of the per unit method as it is found in some of the early university studies.
So the per unit method, in this case, we're going to use it to determine the generator's terminal voltage. All right, the characteristics that are given is that the load is at 600 kilowatt at 0.8 lagging. So this is our power factor of our load. And then again, I'll state that the load is at full load current at 0.9 pu. Determine the generator terminal voltage. All right, so we have a few line components here. We have our transformer, 11 to 3.3 kV transformer with a 1 MVA capacity, and it is an impedance 7%. We also have our line characteristic over here. So the first step in this method is we have to work back from the load characteristic. So we have the load characteristic. The first thing we do is we determine through the power equation, right? This is just the basic power equation. We determine the current that is indeed flowing in our load. Then we make that a base value to our common base, which is our transformer. We're going to use the transformer as the current base. Then we take that 1 MVA value as our base value. And then we divide it by the V base, which is 174.955 amps. Right, so this is our base amperage. So now we want to take base amperage and convert it to per unit, because we're using the per unit method. So load current divided by the base current, your per unit value of your current at the load. All right, so now we have the current at the load. The components that we still have to solve for are the transformer over here, and then of course the line. The transformer is at 7% reactance. We use the transformer as our base. All right, another thing we need to determine is our line value. Here we have our line impedance. Here we have our base value, which we have decided, and our voltage value that we have decided as the given base. All right, our line per unit value in impedance. It's simple. We basically use the current that is drawn by the load, and we know for a fact it'll also run through the transformer, which is at 7% impedance, and as well as at 0.26, the line per unit impedance. You add them up and you basically get to this value over here. Now this value is in the voltage at the terminals of the generator in per unit. So what you have to do is, yet again, transfer that to an actual value. Is you multiply it with its V base. So the actual per unit value of the generator multiplied by its per unit base, which is obviously 11 kV, because its output is at 11 kV, which was its base, giving you a total of 11.968 at angle 9.34 degrees.